Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab. And in the search question number 45, enter. So the question is like jump game 2. In the previous video, we already covered jump game 1. And this is the jump game 2. So why we are doing this? Because this is more or less like a similar program only. So click on it. So let's read the question. You are given a zero index array. So that, which is perfectly fine because in Python, all the index start from 0 and array of integer nums. So nums is our array, or you can say like a list of length n, which is fine. You are initially positioned at 0, so you are starting at the 0th position. Each element, so nums of I, represent the maximum length of a forward jump from index I. So it like same problem description. So it says like each this number, like what this number like represent, this number represent this, like how much maximum jump you can took from if you are standing at this position. So if you are standing at this position, you can maximum take 2 jumps. If you are standing at this position like a 3, then you are maximum taking a 3 jumps. Right. So now in okay, so each element number represent the maximum length of the forward jump. In other words, if you are a number, you can take the jump num I plus f, which is fine. Now we need to in the previous video we need to find whether by taking any number of jumps can we reach at the last index. If we reach at the last index, we need to return true or false. But in this case, a little bit different. In this case, they mention return the minimum number of jumps. So we need to return the integer. If you see, we need to return the integer, we need to return the minimum number of jumps to reach n minus 1. N minus 1 means like the last index basically. The test case are generated in such that you can reach nums and n minus 1. So, so they mention they have written the test case in such a way you don't worry about that whether you are going to reach at the last position or not. You are going to definitely reach at the last position, but what are the minimum number of steps you are going to take, right? So let's look at the whiteboard. So this is the like problem statement. Like first we look at the first example, 23114. So if we initially we are at this position 2. Okay, so from 2, we can take maximum 2 jumps. So 0 plus 2, we can take maximum 2 jumps. So if we could take this jump, maximum 2 jump, then we are here. Okay, which is fine. Then if we are here, we can take one more jump. Then we can take one because we are at here. So we can take one more jump. Now we are here because maximum jump, we can take one. Now we are at here, then we can take maximum one more jump. Okay, so we can take maximum one more. So how many jump we took? One, two, three. But is this the minimum number of jump? Because we need to return the minimum number of jumps. All right. So let's look at the other way. So if we are the two, it says maximum 2 jump, but we can take one as well. So we can take one as well. So we can take one as well. So if we can take this as well. Okay. If we take this as well, now here we can take maximum 3. Now we will be reach here. So in this case, if we follow this route, this one and this one, in this case, we took 2 jumps, right? So minimum number of jump is 2, not the 3. But how we are going to know whether we need to take this or whether we need to take this? So basically, we need to check this as well. We need to check this as well. Once we check both the things, then we are only going to update the number of jumps. All right. So as an example, okay. So let's so we need to uh, also we need like in the last video we want to reach at the last index. All right, and we need to return true and false. So the same logic we are going to apply. We need like what is our intention? Our intention is like if I can take like high more and more jumps, right? Like then only if I take like small jumps, right? Then we, we can't reach the minimum. We are finding the maximum. So if I took more jumps, right, more jumps, like high jumps, then like it is easy to calculate the minimum number of jumps, right? Then it is calculate the minimum number of jumps, or you can say minimum number of steps, right? So that's why we are taking the one variable farthest. So farthest means how can we reach farthest? How can we reach farthest? And jumps like this is normal variable which we are going to return like integer. So we definitely need this variable. So we need the like one variable jumps which initially is 0, which is fine. We need this variable, right? And like like from here we can go here, from here we can go here, right? But shall we take this route or shall we take this route? We don't know. So what we are going to know, what we are going to check, if we are the current index from here, like what is the maximum jump we can take, and from here what is the maximum jump we can take. So if we are here, what is the maximum jump we can take? So this index. So if we are here, the current end will be 2, current end will be 2. But if we are here, the current end will be 4, the current end will be 4. So we need one more variable to calculate the current end. Current end means if we are the current index, how far we can reach. If we are the current index, how far we can reach, right? So let's first scan this. So okay, so we are the this position 2. So where, which jumps you can take? So you can take this jump and you can take this jump, right? So if you are 2, what is the farthest you can take? What is the farthest you can take? So 0 plus 2, this is the farthest. So you update the farthest to 2. So you update the farthest to 2, right? So you update the farthest to 2. So if you are the 0th index, you can update the farthest to 2. And like see, it doesn't matter whether you take this route or whether you take this route. So when you are at the first index now, so the number of jumps always be incremented. So the number of jumps will be incremented to 1, right? And the current index, what will be the current index? Current index is also 2. So current index is also 2. So we update it to 2. Okay, so we update it to 2. Now next, now now we need to scan the next element, because we don't know shall we take this route or shall we take this route. So what we are going to check is, we will check all these two, like shall we take this route or shall we take this route. Basically we are check like all elements. So now like I is equal to 0, then we already updated all these elements. Now I is equal to 1, we are at here, I is equal to 1. From here, where we can reach maximum? So 3 plus 1, 4. So here we can reach maximum. So update the farthest element to 4. Okay. Do we need to update the jumps? No, because jumps only we are going to update after checking these two elements. After checking these two elements, because we don't know which route we have to take. We don't know which route we have to take. So first we have to check this route as well, and then we have to check this route as well. If we take, if like first we are on the 2, then we already played 0 to 2 and jump 1 and current index 2, because when we are in the initial position, doesn't matter whether we go to 3 and whether we go to 1, we will take one jump. That's why we update 2 1 2. Okay, but now we will start from 3 or we will start from 1. So to do that we need to check both. To do that we need to check both. So if we are on the I is equal to 1, then maximum is 4. Okay, fine. If I is equal to 2, I is equal to, then we are here this index, in the loop we are in this index. Now 2 plus 1 is equal to 3, so maximum we can reach, if we are here we can reach 4, if we are here we can reach here. All right. So is 3 is greater than 4? No, is 3 is not greater than 4, right? And we have scanned both the elements 3 and 1. We have scanned both the elements. Now we are going to update the jumps. Now we are going to update the jumps. One jump is, we already checked these two elements, it means we took one jump. Now we are update this element. And what is the current index? Current and means which index we are going to take, that basically the farthest index, farthest index. So we will going to update it to 4. Correct. So this way we need to do the our logic. So let's uh write in our code. So we need a three you can say variable jumps which we already take. Okay, then farthest we need, and current end, or you can say current farthest. Okay. Now we need to run a loop. Okay, for I in range of length of nums. Okay, we will scan all the elements. Okay, if if okay, do one thing. Before that, let's check one more. If there is only one element, Let's suppose there is only one element, right? Then how many jumps required? If there is only one element, how many jumps required? Zero jumps. All right. So we will take the scenario outside of the loop, right? So if length of nums equal to 1, we are going to return jumps. Jumps means zero. All right. So we are going to return jumps. Okay, fine. Now, if greater than 1, then we are going to scan. Okay. For I in range, so we are at zeroth index. We are at zeroth index. Now, first we have to calculate what thing we have to calculate. If we are at the zero index, where we can reach maximum. So farthest is equal to max of current farthest, comma I plus I plus nums of I. Nums of I means this element 2. Because if we are the here, where you can maximum reach 2 plus 0, maximum you can reach second index. Farthest is just basically the index number. Index number. Current end is also the index number. So 2 plus 0 is equal to 2. Farthest you can reach here. Right? Okay. So once we are on the 0, right? So we need to update the number of jumps as well. Right? So the condition is if I is equal to current end. So I is equal to 0, current end is equal to 0. If I is equal to current end, we are going to update the jumps is equal to jumps plus 1, and we are going to update the current end is equal to farthest. So now when we are at here zeroth index, farthest where we can reach maximum farthest is 2, because if we are here, maximum you can reach here, which is fine. How much jump you take? One jump you take. What is the current end is 2, so update also, cross that and update that. Okay, so 2 1 2. Okay, now when I is equal to 1, so I is equal to 1, right? So now we are at here. Now we are at here. Again, we are going to calculate the farthest. So if we are here, where the farthest we can reach? The farthest we can reach is equal to 3 plus 1, 4. So 3 plus 1 is equal to 4. So we have to update the farthest. So we update the farthest. Farthest is equal to maximum of current farthest. Current farthest was 2, and the other one is nums of I plus I, which is 3 plus 1 is equal to 4. Out of 2 and 4, which one is the maximum? So 4 is the maximum. We are going to update the 4. Okay, so shall we update our jumps? So shall we do this? No. Why I put this logic while I is equal to current end is because in initial we took the maximum jump. We took the maximum jump and we update our current index to farthest. So, and we are going to update the jumps until unless we are not going to check these two. These two means our till our when I is equal to current. These two means I is equal to current. So until we reach our loop here. So we are not going to update. So now I is equal to 2. So now is equal to 2. Now let's calculate the farthest. So 2 plus 1 is equal to 3. So still the farthest is 4 because 3 is not greater than 4. Still the farthest is 4. Now I is equal to current end. So now I reaches here. Now I reaches here. Now I is equal to current end. It means I have checked this index. I have checked this index. It means I have checked this route. I have checked. It means I have checked this route and I have checked this route as well. All right. So I check both the route. Now I am going to update the jump. So jump is equal to jump plus 1, 2. Now the current end is equal to farthest. Current end is equal to some from where we are going to start. So from where we are going to start. So now we are going to start from here. Current end is equal to farthest. Right. But as soon as we reach here, do we need to check further? No. Do we need to check further? No. So here we are going to put our logic. If current end is greater than or equal to uh, length of nums minus 1. If it's already, then break it. And at the end, we are going to return jumps. So let's run it. So there is some problem. Okay, it's farthest. Okay, that is the jumps. Our sample case has been accepted, so let us to submit. So our solution has been accepted. It beats 88% of the people, and memory wise as well, 78% of the people. So like this solution, like in the if you check my last video, now in the last video, I am also running this condition, right? I am also running this condition and one kind of condition like this. If current index already reaches, then I am like stopping. All right, so this code already in the previous video, that's it. So but we need to calculate the jump, so we need some variable, so we need to calculate the jump, so we need to increment that variable. But when we are going to increment, that is the main logic. When we are going to increment, the only thing is when we are going to check all the possible condition, only then we are going to increment all the possible condition. Means, so if we are at the first index, maximum you can reach here. So in between, what are maximum you can reach here? So which means current index is 2. So until my I reach 2, I am going to check. So until my I reach 2, 2 means current, and I am going to check. I am going to check. So if my once I might reach my current index, then only I'm going to update my jumps. So we are going to check this. We are going to check this route. So from here we are going to we know we will go further. From here we are going to only reach here. So that's why like we check both the routes, and then we are going to update our jumps. So that's it. That's the end of the video. You can also try this question. Thank you.